Okay, so section 2 is very similar to section 1, as in we're still simplifying identities, but the difference is now we're verifying them. So we need to proving that the left-hand side, the left side equals the right side. Okay, so the only difference is now you're going to know what it equals. Okay, so instead of having to simplify and not know what it equals, now you're given what it equals. You just have to figure out how to get there. Okay, and just like on the first lesson, there's different ways of doing this. So if you do it a different way and I do it a different way, doesn't mean either one's better as long as it's mathematically right. So you can't do something that is not algebraically correct, but if you simplify this a different way than I do, it doesn't mean you're wrong. Okay? So I know I need to simplify this side to be sine squared. Okay, so if I look at secant squared minus 1, if I look at my Pythagorean identities, I can replace this with tangent squared. So I have tangent squared or secant squared. Okay, and when you're doing these like step by step, you either need to draw arrows or something to show me like where the next step goes. So either you're going all the way down, all the way across, or you draw arrows to represent what's going on. So from here, if I know I want it to be sine squared, I need to change everything to be sines and cosines. So if you look at your sheet, if you look at your quotient identities, you can change tangent to be sine over cosine. So since this is squared, that becomes sine squared over cosine squared. And then I can change secant squared, if you look at your reciprocal identities, to 1 over cosine squared. Okay, well if you have a fraction divided by a fraction, that's the same thing as multiplying by the reciprocal. So this becomes times cosine over 1. And then my cosine squareds cancel. So then I get sine squared, which is what I wanted. So once you get to the point that you're done, you can box it in, or I just put a big check mark so that I know that I'm finished that problem. Okay. Okay, anytime you see fractions, in order to combine fractions, you always need a common denominator. So the very first thing you do is I need to multiply by what they need. So this one has a 1 minus sign, so I'm going to multiply this one by 1 plus sign on top and bottom. That has a 1 plus sign, so I need to multiply by a 1 minus sign. So then I have 1 on top. Okay, when I multiply this together, that gives me 1 minus sine plus sine minus sine squared. Minus sine plus sine cancel, so this is just 1 minus sine squared. Okay, then I multiply the other fraction. I get 1, this is not 1, I forgot to multiply on top. So that's really 1 plus sine, sorry. So when I multiply this one on top, that gives me 1 minus sine over, same denominator this one has, so 1 minus sine squared. Okay, so from here to here, combine it into one fraction. Well, when I combine 1 plus 1 is 2. Sine minus sine, those cancel, so I have 2 over 1 minus sine squared. Okay, well if you go look at your Pythagorean identities, 1 minus sine squared changes into cosine squared. Okay, the reciprocal of cosine is secant, so 1 over cosine squared would be secant squared. Since I have a 2 up there, this just becomes 2 secant squared, which is what I wanted, so I'm done. Okay, so if I look what I have on the left and I look what I have on the right, secant and cosecant both deal with sine and cosine. So I would want to change these to be sines and cosines. Well, if you go to look at your quotient identities, tangent changes into sine over cosine, and cotangent changes into cosine over sine. Okay, if you have two fractions, how you get those added together is you need to have a common denominator. So I'm going to multiply this one by sine, and this one by cosine. So now I have sine squared over cosine sine plus cosine squared over cosine sine. Okay, well if I add together, now that they have a common denominator, I have sine squared plus cosine squared over cosine sine. Okay, so I have sine squared plus cosine squared. So I go look at my Pythagorean identities. That gives me 1. Okay, then 1 over cosine is secant, and 1 over sine is cosecant, which is what we wanted. So we're finished. Okay. Okay, and I always try to get the left-hand side to equal the right-hand side. If you do it vice versa, it doesn't mean you're doing it wrong, okay? I just think usually the left-hand side is more complicated, and the more complicated it is, the more you can substitute things in for it. Okay? Okay, so if I know everything on the right-hand side has to be sines, because I have 1 minus sine over sine, so the first thing I do is I look to see, can I change those two terms to have sine in them? Okay? So cotangent squared, if you look at your quotient identities, is cosine squared over sine squared. And then in my denominator, I can change cosecant to be 1 over sine. Okay, because that's your reciprocal identity. Okay, now I'm going to leave the numerator alone for a second, and I'm going to focus on the denominator, and I need these to be able to be added together. So I need a common denominator, so I'm going to multiply this one by sine. Okay, so I didn't do anything with the numerator. It still stayed cosine squared over sine squared. But my denominator now, if I multiply this by sine, that becomes sine over sine plus 1 over sine. So since those now have a common denominator, this now becomes, numerator stays the same. The denominator becomes sine plus 1 over sine. Okay, well we're not done yet because I still need 1 minus sine over sine. So fraction divided by fraction, multiplied by the reciprocal. So I would have cosine squared over sine squared times sine over sine plus 1. Okay, well the only thing that's going to cancel now is my sine. I have a sine here and a sine squared there, so this one cancels and I put just 1 there. So I have cosine squared over sine plus 1. Okay, and I'm still not done because I need everything to be sines. So I'm good on the bottom because I have sines, but on top I still have cosine squared. So I want to see what can I replace cosine squared with that has sines in it. Well, if you look at your Pythagorean identities, cosine squared can be replaced with 1 minus sine squared. Okay, so we're getting closer. Not quite what it looks like. So I need to get just 1 minus sine on top instead of 1 minus sine squared. Then I need to get rid of this sine plus 1. Well, 1 minus sine squared, that's a difference of squares. So that factors into 1 plus sine, 1 minus sine. Then I still have the same thing in the denominator. So then what happens is, so 1 plus sine and sine plus 1, those are the exact same thing. Those cancel. So I have 1 minus sine over sine, which is what we want it to equal. So we're finished. Okay, I'm going to do 2 more. Both of these are ones that are very similar to your homework problems that I'm pretty sure you probably will have questions on. So I want to make sure I do both of these to help prepare you for your homework. Okay, so I know I talked about before how the importance of having the x and y's or theta or beta, whatever they give you attached. If you look at number 5, it has x and y included. So I need to be very careful about which ones are which because those are different angle measurements. So you can't interchange x and y. That's why it's so important to have that on every single one of them, because that determines what your angle is. Okay, so if I look at the left and I look at the right, I have all tangents on the left, I need to go to cotangents on the right. Well, cotangent is reciprocal tangent. So if I look at what I need all my x's and all my y's to both be in cotangent. So I'm going to change this to be 1 over cotangent x plus 1 over cotangent y divided by 1 minus 1 over cotangent x, cotangent y. So I changed everything, because on the right hand side, everything was in cotangents. Okay, I have fractions. In order to combine those, they have to have a common denominator. So this fraction on top, I just do top and bottom separately, this one you're going to have to multiply by cotangent y, and this one you're going to have to multiply by cotangent x. Okay, so that's going to become cotangent y over cotangent x, cotangent y, plus cotangent x over cotangent x, cotangent y. Okay, well then in turn you can make that one fraction. Okay, so that's the numerator. Okay, so then the denominator. I need a common denominator. So this one has cotangent x, cotangent y, so I need to multiply the left one by cotangent x, cotangent y. So then I would have cotangent x, cotangent y over cotangent x, cotangent y minus 1 over cotangent x, cotangent y. So as one fraction, that would become cotangent x, cotangent y minus 1 over cotangent x, cotangent y. Okay, fraction divided by fraction. Now you have 1 and 1. We multiply by the reciprocal. So I have cotangent x plus cotangent y divided by cotangent x, cotangent y times reciprocal of the bottom one, so cotangent x, cotangent y divided by cotangent x, cotangent y minus 1. And then cotangent x, cotangent y, then our diagonals cancel. And I get cotangent x plus cotangent y divided by cotangent x, cotangent y minus 1, which is what we needed. Okay, last one, square roots. In order to get rid of a square root, you need to have something squared. So if I want to get, I know I need 1 minus cosine over here, and I have 1 in there, so I need 2 of those. In order to get 2 of those, you need to have another one that you're multiplied by. So I'm going to multiply this, top and bottom, by 1 minus cosine. And you can't just choose to multiply top or bottom, you have to do both. So on top, I now have 2 of those, 1 minus cosine parentheses squared. On bottom, when I FOIL that, I get 1 minus cosine plus cosine minus cosine squared. Okay, which then simplifies. That is not what that is. Cosine x parentheses squared. So cosines cancel. So that's 1 minus cosine squared. Okay, if I look at my Pythagorean identities, I can replace 1 minus cosine squared with sine squared. Okay, now that I just have a squared on top and a squared on bottom, the square roots cancel them. So then this would just become 1 minus cosine over sine. Okay, you don't have to have the absolute values on there. That's just saying that has to be an absolute value. The reason why, you can't take the square root of a negative. So it's just telling you that that's a fact, that this would have to be positive for this to work, but you don't have to put that on your answer. Okay, these are just a few examples of problems. I tried to give you ones I thought would be more complicated. This is just like your homework from 5-1 from the 2 through 68, okay? But you now know what this is supposed to equal. So it really should be, in theory, easier because you have a starting point where you need to go. If you ever get lost, change everything to sines and cosines. That's always a good place to start because everything will turn into that. Okay?